I want to welcome everyone to our annual HPC update. In particular this year, we want to thank everyone for doing all the surveys. We really appreciate it. This has been a very exciting year for us with all the different studies, and it's due to your help and inputs, thoughts, and ideas that have allowed us to actually create all the information and do the research we're doing. So we truly appreciate that. Let's see, there we go. So a couple important notes. If you want to copy the slides, please go to the website and register, or leave a business card with one of the Hyperion team. But the fastest way is if you just register at the website, and then we send the slides to everyone who's registered at the website. Okay. So also and this is the point of the website, but this is where we're posting some of the new research we do over time. So right now there's only a few of them there, but under the sample reports, we plan to start posting publicly a lot more of our research, because our plans are to make more of it available to the overall community. As you probably know, the Hyperion research team, but just to remind you, it's myself, Steve Conway, Alex, Bob, and I think Nishi is in the audience somewhere. There he is in the back corner. And then Mike and Kurt are both over by the exit sign. So you have most of the team here if you have any questions or would like to talk with us. So with that as just a background, the agenda for today is we're going to go over some recent research results. As I've mentioned before, you're going to see individual slides, but each slide represents a very large study. So if you're interested in the topic or want more information, we're just doing the sampling of the studies. Then the usual update on the HPC market. And then Alex is going to announce our new cloud computing numbers. I'm going to steal a little of his thunder on his and tell everyone we are announcing that 2019 from our counting is the first tipping point for the use of cloud for HPC jobs. And Alex is going to walk through what we mean by a tipping point and how large it is. And then Bob's going to cover the quantum computing update and what's going on with Exascale, and then also the innovation award winners. So with this one also, sorry for so many background slides. I think most of you know we do, but we do attempt to track everything sold in HPC, AI, HPDA by 28 countries every quarter. But these are basically the different things that we do for a living. And also the HPC User Forum. For those of you who haven't been to a forum or checked out the website, we do post all the presentations here. So if you're interested in what's been going on in HPC for the last decade, I think we're up to 10 years on the website now, we literally have everyone's presentations for the last decade. So if you're interested in what a particular vendor said they were going to do 10 years ago, then 5 years ago, and then last year, you can do some fun comparisons that way. Some important dates for your calendar. These are the next meetings we're going to have. We'll be doing a number of international ones too, but we haven't set those yet. But March 30th to April 1st in Princeton, and September 8th to 10th in Tucson. And we also want to thank the steering committee members for the HPC User Forum. They're the ones who set the agendas, the research topics, and everything else like that. We appreciate that. And with that, I'd like to walk through some of our recent things. We're announcing for the first time our forecast of what's going to go on with ARM processors. And in this particular table, like we do a lot of things, we take this revenue line there, it's the amount of systems. So it's not the money going for just the processor, it's the system value with computers that have ARM processors inside of them. The second line is showing the number of ARM processors that we predict are going to be sold. You notice it starts from a small number, and I've often mentioned is if you start with small numbers, you pick the right endpoints, you can show some interesting growth rates here. But the reality is ARM sales we're projecting to grow at a very high rate, above 60% a year. So we think it's going to be very strong in the market. And with that, we always like to show some charts. This is a historic view of what we call tipping points. Since you're seeing ARM processors as a tipping point, and Alex will be talking about another tipping point, this is when x86 kind of took over the world. And if you remember before 2001, 2002, the x86 processors really were not good enough for most HPC workloads. And once they got through a threshold where they were good enough for most HPC workloads, two things happened. One, a lot of people switched to x86 because they were a lot less costly, but ignited growth in the market. The market almost tripled in just a 2-year period there. So we're hoping with some of the new things going on, we'll see similar type changes in the market. And with that, I'd like to hand it to Steve.
Sure. Thanks, Earl. And just a reminder that anybody who registered for this is going to get automatically a copy of the slides sent to you, so don't need to take notes or any of that. Just want to give a really quick recap on what's been happening with artificial intelligence. We've been doing a whole series of very large worldwide studies on this, mostly for government clients, not just in the US. And this is the picture that emerges talking with people who are deeply involved in this. And it's not just people who are traditional HPC people, but it is limited, our view, deliberately to places that are using HPC to enable AI. And this is the picture that emerges right now. There's pretty good consensus that we are at a period, we're still near the beginning with AI as far as capability goes. Lots of emphasis has been on training and lots of progress there. Just more recently, the emphasis is starting to shift to inferencing, the ability of the machines to guess better, to have better intelligence and guessing ability, intuition, but that's not so far along. So the situation right now is we're in a period where most of the problems that are being tackled require many observations. That's the training, but not a lot of choices like partially automated vehicles. The choices are things like stop, go, left, right, fast, slow, things like that. Few choices, but still already very, very useful for image and voice recognition, as you know. Where things are headed, or where people are trying to push them, is toward the right-hand column there, where inferencing in particular gets to be stronger. And so, for the same task that is being done today, a lot less training will be needed if you have a bigger brain to work with. And that's what people are pushing for. And so then you end up, eventually, it's hoped, with independent decision makers that are capable of adapting to circumstances in real time, kind of a thing. And you can see some of the things that would be possible then when that happens. This is our updated forecast for this part of the market that uses HPC. We pushed it out to 2023. And what you see there in Table 1 in the lines, the first line is just HPC server revenues on a worldwide basis. The second line is a subset of that for high-performance data analysis, which is just data-intensive computing that it uses HPC servers. And the third line is a subset of that, which is AI. Table 2 breaks that down into the main AI methodology categories: machine learning, which still is the biggest one right now, deep learning, and other. Other is mainly something that doesn't always get talked about enough, but is extremely important, which is graph analytics. This is still true. Most of the really important, economically important at least, use cases for AI are going to involve coupled environments, meaning on-premises and cloud environments closely coupled. And examples are automated driving systems where you're going to need local communications with other cars in the local environment, but also citywide and even region-wide kind of cloud-based control. And you can see good examples of that today. For example, in Guangzhou, China, where the Tianhe supercomputer, a very big supercomputer, 60% of the cycles on that machine from the beginning have been devoted to things locally for the city and the province of Guangzhou, and the single biggest one by far is traffic management. Healthcare is kind of the opposite, because in healthcare the cloud stuff is already there. When you communicate with your healthcare providers, you're using a cloud. When they communicate with each other, the same thing. But the HPC systems are starting to come in, and we have good examples of that now in order to be recommender systems, decision support for diagnoses and treatments. And then, Alex?
Morning, guys. Can you hear me? So one of the areas that we've been tracking recently is this emerging ecosystem of new AI-centric hardware. So there's a number of companies, both large and small, who look at the growing AI ecosystem and are looking at new ways from the hardware level to attack these problems as we go forward. So there are some some really kind of interesting announcements that have come out in the past 6 months. One of the big ones was Cerberus's announcement with DOE. But as you can see on the screen, there are a number of startups as well as many familiar faces who are doing new and different things in the world of AI from a hardware perspective. And another thing that we developed about a little over a year ago was our cloud assessment tool. We're still in the process of getting feedback and doing beta tests on making sure that what we capture is accurate. And I will talk about this a little more later, but the goal of this tool is to allow end users to understand where their workloads fit, whether they can only be run in an on-premise environment or they can be run in multiple different environments like a cloud or a hybrid environment. And this tool breaks down different characteristics of various workloads and helps them understand where they fit on that scale. So if you have any questions about it, please feel free to email me and go check it out. It's very interesting. And with that, I'll go over to Steve.
Hey, thanks. So we'll do this year about 20,000 surveys around the world to get our data. And we have different methodologies, but one of the methodologies that is gotten to be really popular is what we call a pulse survey. It actually, we didn't come up with the idea. It actually came out of Deborah Goldfarb at Intel, but it's very popular. And the way that it works is that we have a panel of, at this point, about 1,200 people from the HPC community worldwide who have agreed in advance to take these surveys as long as they take no more than 10 minutes each. And the questions are not open-ended. The questions are, multiple choice and things like that. But for certain types of information, and it's mainly used for kind of probing in areas that where there's not enough clarity, seeing what's happening and so forth. These are very, very effective, and they also, it turns out, correlate really well with larger surveys that we've done. So we have pretty good confidence, even though they're not meant to be statistically valid. The N numbers here are usually between like 60 and 250 or something like that. But these generally they're very low cost, but they generally take, from the time that the questionnaire is approved, only 3 or 4 weeks to get the results. And this is just an example of kind of what the results look like for a couple of them. This is from somebody who's very interested in what's happening with MPI in the cloud right now. And this other one is, where are GPUs being used around the world? So, and Bob?
Hi, how's everybody doing this morning? I'm here to present basically a study summary that we just completed for NASA. It took us about a year to do the work, and if anyone wants more details on it, I'll be presenting at the NASA booth this afternoon at 12:30, and there's also some other NASA presentations throughout the week on this particular topic. But the bottom line is, about a year ago, NASA came to us and said, would you be willing to help us explore options for a bespoke HPC targeted for the weather and climate community? And ultimately, the perception within NASA was that there was a growing gap between what their particular software suites required to execute properly and what was going on in the commercial HPC development trajectory. And what they were hoping for was a sense of what would it take to go out and basically build the kind of HPC that would fit our workloads. And so the focus of this thing was to really, stage one was to go to a number of weather and climate research centers around the world. We ended up really talking to about 15 different organizations, ECMWF, LANL, NOAA, ORNL, a number of other weather centers, and collected 2 really important packets of information. The first one was, what are your operational requirements for doing weather and climate research, say for the next 3 to 5 years? And also, how do those operational requirements translate into HPC specifications? And so we conducted a number of interviews. And what that gave us at the end was what we just called the HPC spec sheet. and we had a 2-page description of what the dream HPC for weather and climate would be for NASA. And then we contacted what I consider to be the usual suspects, Cray, Dell, EMC, HPE, and IBM, and said, how would you be interested in building this system? What would it cost? And what would it take for you to realize this kind of system? And the result was actually, I thought, very interesting. And the bottom line was none of the vendors were terribly interested in building a custom HPC. They basically said that we had one company say there was no amount of NRE that would justify a custom system at this point in their development, that the opportunity costs are just too great to pull off people to develop a one-off system. And so while that was ultimately, I could think I don't want to say the bad news, but maybe the surprising news, really what we found out of that was that the vendors were very interested in working with NASA and saying, okay, let's think about how we can go forward. And what are some of the things that we would like to see from an organization that's trying to modernize their workload? And this is really why I think we wanted to present this study today, because the fundamental reality is NASA is not alone in this. There's a lot of folks out there that have existing workloads that, I don't want to say they're 2 million lines of Fortran, but maybe they are, that haven't been looked at in a number of years. There's a profusion of new opportunities right now in architectures, processors, access models. You're going to be on-prem or in the cloud. How do you modernize your workload? How do you refactor your software to get this stuff done? And NASA was one of the organizations that was bold enough to say we really need to start thinking about this. And so we presented them with a number of options that the vendors came forward with. It said, first off, things like improved benchmarks. You need to characterize your workloads more accurately. We just can't say, do you dual impact, do high performance conjugate gradient. We need to accurately characterize your workloads. The way HPCs are being built today, the rewards for getting the architecture to match your workloads are tremendous, and the penalties for having an architecture that doesn't respond to the workload you have can be really expensive, and you ultimately end up with a machine that's not very useful. So we came up with a number of different suggestions, the big one being co-design conferences. Have an organization seeking to have an HPC that meets their unique workloads, to work with the vendors to think about how they can best design a system and characterize their workloads in a way that allows it to be best modernized and brought up to date. So the study took an interesting turn, but I think at least from NASA's perspective, this is really going to help put them on the right road to getting the kind of system they want that matches what the commercial sector is willing to drive advances on. And so hopefully we're going to see more progress in that in the coming years. So I'm going to switch it over to Earl now, who's going to give the long-awaited HPC market update.
Thanks, Bob. So first of all, the top trends in HPC right now, if you remember, 2018 was an extremely strong year. We saw 15% growth. Our forecasts were 8%, so we're off by a factor of 2 this time, or last time. Right now, for the first half of 2019, it's looking very strong also. It's always hard to tell, what's going to happen the last part of the year, because the last 2 quarters are the strongest quarter. So even though the 6.7 billion is less than half of the 14 billion of last year, it's actually on the trajectory of being another very strong year. And some concerns we have, for example, on the top 500 list, there isn't a new system above number 20 or 22, 23 on the whole list. So the very large systems aren't being installed yet. Now, they're going to have a massive impact when they get installed. And our philosophy really, or belief, is really there's a lot of funds that have had to be pulled away to fund those very large systems. But anyways, right now, 2019 is looking quite strong. We're also seeing a lot of new buyers enter the market. And there's a lot of different terms being used for this. Frequently, people refer to it as convergence, or where you have enterprise users that are really moving into HPC. And what's driving that is AI and big data, because they want to do new things, new different things, and what they realize is they really can't effectively do that on non-HPC hardware, software, and systems. And so here's what the first half of the market looks like right now. The supercomputer segment's at 2.6 billion. Divisional 1.2, departmental 1.9, and workgroup just under $1 billion. So the one part that still concerns us some is the workgroup segment hasn't really recovered from the recession. And that's been, what, almost a decade now we're talking about, or getting close to that. We're also doing many studies. Steve, I think we did close to 12 cloud studies this year, 11, 12 studies on all different aspects of cloud usage, what's going on there. Because our first theory was that the smaller users were going to the cloud instead. We're not sure that's true, because what we actually are finding in our studies, they're keeping their systems twice as long. So we're not sure what the answer is there. Does that mean that it's gone on-prem to the cloud, or does it just mean that they're staying with existing hardware? So that's one question that we're trying to answer and figure out. So here's how the market last year broke out by the different verticals. The bio life sciences is strong. Interesting thing that one of our clients brought up is, what if you just lump some of the real traditional manufacturing together, CAE, EDA, and it turns out if you lump some of the manufacturing segments together, they actually become the largest segment there. Now at the same time, if you look at government and lump all the government pieces, then that gets larger too. But one part here is we're going to be asking your help to help us over the next year to probably change this chart into 2 charts. Because right now it's still kind of a mixture of verticals, application areas, and that, and we want to actually have 2 views of the world that are a little cleaner. So any advice you can give us, we'd really appreciate that. And here's the market by vendor shares. Over this week, we're doing some interesting little, I don't want to say games, we're just having fun with the numbers. For example, taking Cray and add it to HPE and say, what does that look like historically? Because whenever you have an acquisition, we have to go through the discussion of, well, when do we put the Cray numbers along with HPE's numbers? And you really want to do that for us on a yearly increment. In reality, it's a quarterly increment. But if you add, Cray to HPE now, the gap between HPE becoming dominant in market just grows quite a bit here. And then drilling down just at supercomputers, that previous chart was for the whole HPC market. This shows a 4-year view of who's really been selling all the supercomputers. And if you notice, we went through a 4-year period where there was stagnation in the market. And then last year we mentioned that the market really had changed substantially. So it really changed by $1 billion in 1 year there. The part that's just fascinating, because we have to do 4 or 5-year forecasts in every category, the supercomputer market will fundamentally be redefined in the next 3 to 4 years. Because when you have $600 million systems, and Bob will be covering in more detail, but if you have 2 or 3 in 1 year, that's half of this number here, just off of 2 or 3 systems. So that's something that we're looking at. And here's the regional view of the market right now. We are also making some adjustments in the regional view. And traditionally, we always separated Japan out of Asia. Going forward, we're going to also separate China. We've been receiving a lot of requests to see the China numbers separated out. So you'll see multiple views, the regional view. And we actually are able to do that now because we have a 28-country structure underneath this. And we track everything by all those countries. So we wanted to show in just a kind of historic view of the whole market. We always refer to the roller coaster effect and the forecast. You can see our forecasts are always a little smoother than reality has happened, but you can see the continual roller coaster effect that's been taking place in the market. And also why our concern about the work group segment. If you can see in 2005, the work group segment was actually larger than it is today. Because after the recession, it continued to shrink and shrink. So then in addition to just the server portion, this shows the storage, middleware, applications, services. If you look at this portion of the market is roughly $28 billion today, and we're projecting it to reach roughly $40 billion by 2023. And then that, I'd like to hand it back to Steve. And if you want to go forward, it's right there on the slides.
Oh, that's okay. Yeah, we're going to be talking some about cloud computing, Alex also, because things have really shifted, particularly in the last year, but in the last 18 to 24 months. And we've done, as Earl said, surveys about once a month on cloud computing, pretty large surveys globally, and there's some consistency across the surveys here. And the one that I'm talking about here is the very most recent one, a very large survey where we asked people in advance, do you do any HPC in a third-party cloud? And so those were the only people who qualified for this survey, and lo and behold, they said 33% of their workloads on average are now being done in third-party clouds. That is a big jump. So we sort of extrapolated from that using results of other surveys and so forth to the entire HPC community, meaning people, including people who don't do anything in cloud, third-party cloud yet, and come up with a number right around 20%. So 20% of HPC workloads, more or less, are being run in third-party clouds today, mostly from cloud services providers, but also from some of the system vendors who offer cloud services. That is a very big jump. From 18 to 24 months ago, that number stood at just under 10% for the community. And it had stayed at just under 10% for the better part of a decade, and it has suddenly moved up. 40%, as it says here, say that they're in a technical way, their workloads, every one of their workloads could be run effectively in a cloud. It doesn't mean they're going to run them there, because there are some obstacles. And obstacles are some that say we have mission-critical workloads. We're not going to send those to third-party clouds. Some people do, some people don't. Security, but the very biggest and probably ultimate limitation is data locality. You know, when you have very large volumes of data, you know, it really gets to be cost and time ineffective to try to move that data into a third-party cloud environment. And this is agreed to not just by users, but by cloud services. The major cloud services providers also say the same thing. We advise people not to do that. This is particularly important for global corporations that use HPC and who may have large data volumes in multiple places around the world. They may be using different cloud services providers in those locations. But this limitation, and they tell us this, that this is the ultimate limitation. So, you know, these are, we've shown this before in meetings, so I'm not going to go through it, but these are the main, right now, AI markets. These are big enough to be characterized and tracked as markets rather than one-off kinds of things. But what's important here is why has this number jumped from 10% or so of HPC workloads for the community going to third-party clouds up to 20%. And the reason is because cloud services providers have started paying attention to HPC. They've started doing things to enable a broader spectrum of HPC workloads to run effectively, cost and time effectively in their environments. And why have they done that? They tell us because two reasons. One is because the market, and that Earl just reported on, has gotten to be attractive in size. There's a lot of money to be made there. But the second thing is that they see HPC as the key to leadership in AI. That's very, very important for cloud services providers. And the truth is, and that's those kind of 6 use cases there, in every one of those use cases, high-performance computing is indispensable at the forefront of research and development for every one of those use cases. So HPC, what's happening in HPC with AI is really pointing the way toward what's going to be happening with the mainstream markets in AI. So that's very attractive to the CSPs. In this one, different survey, we asked people, where do you run, in what environments do you run HPC? Where do you run it? Tell us all of them. And some you would expect. I mean, on-premise HPC data centers are still the predominant place for running it. We all know that departmental clusters, people don't talk about so more, but also incredibly important. There are a lot of departmental clusters still out there for projects. But one of the interesting results here is this second one that's circled is 36% of these people that responded to this. And by the way, we didn't just ask traditional HPC folks. We asked people, anybody who is running HPC. Enterprise data centers, because traditionally HPC has been an upstream kind of a thing for research in HPC data centers or in the commercial sector for product development. But upstream R&D has been the dominant mode for HPC. This is downstream, supporting live business operations, things like, and we have the lists and we know what they're doing, sales analysis, human resources, all this kinds of things, and integrating HPC systems into enterprise data centers. I think we've dealt now with about 200 and some companies that have made this move. And the reason they're doing it is because they have no choice. their enterprise server technology cannot operate, it can't move data fast enough, it can't process it fast enough. They're being pushed up into the HPC competency space. The other circle there is that the cloud part, and you can see that people are, a lot of folks are running HPC in external clouds there too. And of course, you know, hybrid cloud is the fastest growing mode here. You can see that. And half of all the new, and CSPs don't just mean public cloud anymore. That term is getting to be not so useful because half of the private cloud startups worldwide for HPC are on cloud services provider platforms now. The fastest growing workloads you can read, I won't go over the numbers, but overwhelmingly AI related stuff is the fastest growing, and where the cloud services providers themselves say that more investment is needed is data transport, and this part, very, very important, simulation. Simulation is not going away. Simulation, in conjunction with AI, is growing about as fast, almost as fast as AI itself is, because I can hardly think of an important AI use case that doesn't benefit both from analytics and simulation. Some of them, like fully automated driving, aren't going to happen in our lifetime without the help of simulation. So that's really important. Alex?
So, as Steve mentioned, we've run a number of studies, and our view of the HPC market for cloud has shifted in the past 12 months. So with that, we're going to go into the new updated forecast. So this year was a major growth year for the cloud. We saw across a number of studies, some rather large, that the 10% number of workloads and the budget percentages that we were seeing in 2017 and 2018 have dramatically increased to the point where we have made a major update to our forecast. Before I go into the numbers, I want to be really clear about exactly what this is. So this forecast does not include any users that we would call cloud-born or cloud-only users, users that don't own any HPC gear. These are all users who own on-premise hardware and are also using the cloud to supplement their on-premise system. So the market here for HPC users is going to be slightly smaller than the total market because those cloud-only users are not included. When we say public cloud, what we mean is third-party hosted cloud resources. I just want to be really clear about where that stands. And then also, this is a forecast of HPC spend. So this is from the end user perspective of spending on HPC compute resources in a third-party hosted environment. So with that, here is the orange line is our updated numbers. 2019, we have actually increased about $1 billion from our previous forecast. And projecting out to 2023, we see the HPC spend from the end user perspective at almost $7.5 billion. And then for the first time, we're also announcing the vertical split out of our forecast. This takes in a lot of information from studies of end users, and we've been able to incorporate really high growth areas like the biosciences, geosciences, which includes a lot of the interesting oil and gas things that are going on in the cloud right now. So this is kind of our breakout for the high growth and steady growth verticals from the cloud. And with that, Bob?
Thank you, sir.
I'm just going to jump into a quick summary of our ongoing quantum computing program. But before I do, I just want to mention that whether you recognize it or not, we don't do a dry run of this talk. This is the first time I've actually heard it sequentially. You didn't know that. It was finely orchestrated. But the bottom line here is it really strikes me that it's not that we're jumping from topic to topic in some kind of random fashion. This is what it takes nowadays to try to get a handle on all of the interesting developments in HPC. And I think half this deck would have been pure science fiction 5 years ago. And it just really strikes me as I hear all this. There's an awful lot of interesting things happening right now. So I'm really excited that the sector right now is probably as exciting as it's been in many years, and this is a really good time to just trying to drink from the fire hose of what interesting stuff that's going on. And so one of the things that we're looking at right now is we're really trying to get a handle on what's going on in the quantum computing sector, and we've got this ongoing program. We started, I guess, about a year ago, and really what we're trying to do is get a handle on all the major quantum computing and ultimately quantum technology programs around the world, and we're trying to basically track and assess the major developments around the world in order to just get a handle on where's the wheat, where's the chaff, where's the interesting technologies and developments coming from, the things that have commercial potential, where are some of the evolutionary dead ends or some of the interesting technology that's going on. Right now our focus is primarily on international. We're looking at places alphabetically, you know, Canada, China, Asia, Europe, other places. Ultimately we're going to get a handle on the US, but right now the sense is international. And just to give you a quick sense of how we're trying to add some context here, I get to use the laser. Right now, you know, the coin of the realm in the quantum computing sector, it's not revenue. It's really not relevant right now to talk about dollars. And so what we're trying to do is get a sense of where the research activity is going on. And this is really just a quick graphic that shows quantum computing and communications R&D publications over the last decade. And what you'll notice is that the two blue lines on the top, those are the two lead publication nations right now. And I was very strict in including publications. And so these are generally high quality journals. We're talking the order of Nature and such. We're not talking about publications in journals that no one has ever heard of or does nothing more than print out PDFs, you know, at the behest of the authors. These are quality journals and such. So I place a certain amount of credibility in the numbers we're seeing here. So you can see the two largest publication nations right now are China and the US. And this line here, these two lines here are showing that the US and China are pretty much producing a relatively steady, increasing stream of quantum computer research abstracts and papers. The breakout, though, is when you look at what's going on in China in terms of quantum communications versus what's going on in the US in terms of quantum communications. There's clearly a difference in emphasis here. China is much more interested in looking at what's going on in the communications field than the US is, although both of them are very interested in looking at the quantum computing field. Just to put that in a little perspective, over here I've included the number 3, Germany, just to give you a sense of how far ahead the two US and China are, but that there is international interest in this field as well. The difference in perspective on volume of papers and such, I don't think is too surprising, but definitely what we're finding out that this is certainly a global participation right now. There's no one that's really not at least dipping their toe and looking at quantum computing, quantum technologies writ large. So we're using these kinds of numbers in this analysis to develop a quantum technology ranking system, a 1 to 5 score to basically just try to figure out where the relevant technologies lie and where the interesting things are happening. So at some point, some of this information will be made available, and we're looking for participation from folks to give us their insights. We're trying to reach out to the community as much as we can, because if there's anything this industry, the quantum computing sector, produces right now, it's confusing articles about breakthroughs that no one really understands. And there's a perfectly logical reason for this. This sector is trying to establish a virtuous cycle, demonstrate gains in order to enable continued gains. And so to do that, you can either demonstrate interesting use cases, you can sell product, or you can keep publicity in the public eye so people are interested and funding happens. And we're at the stage right now where trying to kickstart that virtuous cycle means visibility is key. So sometimes we can look at some of these announcements and try to put them in context, but they're really a necessary element for survival of a very nascent sector that's really just at this point trying to get its feet firmly planted in this trajectory that we all hope we'll see in the next decade or so. Right now, just a quick data point, we've now really have about 474, this chart's a little old, we have close to 500 different into autonomous research activities that are out there. Some of them are at universities. Right now, we're really struggling to understand what's going on in the corporate sector. As I said, they do lots of public announcements, but they're short on details from within the corporate world. So right now, we're really doing best in terms of government and academic collection activities. But again, this project is ongoing, and it's relatively well funded by some very supportive clients, and so we're really looking forward to getting a handle on this as we go forward. So I'm going to jump right now into some quick summaries of what's going on in the exascale race. This is a chart that really kind of talks about our impressions about what we're going to see rolling out in the next few years. This chart is already out of date, so don't take more than one picture of it. The bottom, I don't know if anybody went to the NVIDIA talk yesterday that Jensen gave, and it seemed that every other sentence he ended with the phrase, "and in real time." That seems to be NVIDIA's new thing. So I think some of these graphics, it'd be better if we could actually present them in real time. So this is a little bit out of date. But primarily, this is really what we're thinking here is basically in between 2020 and 2025, we're calculating about 26 near exascale and exascale systems are going to be rolling out, worth an additional, if you will, pumping into the sector of about $9 billion. In 2021 alone, we're going to see major HPC development entities, China, the EU, Japan, and the United States, installing maybe 4 or 5 near exascale or exascale systems with a cost of about $2 billion. And then we're going to see 4 to 5 new high-end HPCs rolling out to 2025, annual revenues in the $1.4 to $1.7 billion range. The big question becomes what happens after this exascale bubble hits? Because some of us are leaning to the thought that there's going to be a certain amount of, for lack of a better term, sanity returning to what goes on, and we're going to see machines that are in a slightly more accessible price range. There's going to be a small number of large exascale systems, and basically the rank and file HPC users are not going to be buying into those kind of budgets. So there's lots of opportunity if you're not selling into large DOE programs and such. And I think we saw that we're starting to see that already. I think it's interesting that the biggest change in the top 20 of the top 500 list was due to atrophy with the K system being decommissioned. It changed due to leaving the list as opposed to arriving on the list. And I think we're going to start to see a certain slowdown in what's going on, mainly because these big boxes are just getting very, very expensive. So just to give you a quick summary of what's going on with the exascale plans around the world, and again, the near real time would have been really nice because we know a little bit more about the Aurora box, some announcements we saw yesterday in terms of what's going on with the Intel Xeon and their new is it Ponte Verde chip, their new GPU. It's going to be a 2 CPU, 6 GPU node, some interesting developments there. But the bottom line here is if you run your eye up and down here, you'll see that basically Cray is intimately involved in all these things. And quite frankly, this isn't a surprise. The Department of Energy is very interested in sharing and making sure that developments that happen at one of their labs in terms of software development or optimization obtains at some of the other labs. So commonality in architectures, I think, is something that's going to need to be expected in some of these instances. But basically, we're going to see some really interesting rollouts in the 2022-2023 timeframe for the U.S. China right now is somewhat of a mystery still. They have a number of exascale prototypes that we've seen, one out of NUDT, one out of Sugan, and one out of Sunway. And what we come to expect from China is diversity in architecture. Just because you did it last generation doesn't mean you have to do it this generation. And so we basically have a number of different options going on. There's a certain sense that the NUDT machine may be an ARM-based processor. It may be something that is designed by NUDT. It may be something that's perhaps off the shelf. There is some talk about using the Fujitsu chip. That would be a very interesting activity on a number of levels. Sugan right now is using the AMD licensed version of their chip, and they're making it more their own as generations progress. And Sunway's building basically a massive homogeneous architecture, not turning to GPUs, but just putting a whole bunch of cores on a single chip. And they are driving to be probably the first to field what ostensibly would be an exascale system, but we've heard Chinese roll back on that. They say exascale is going to be the peak number, and they're shooting for about 60% efficiency on LinPack, so we're looking at 500 to 600 petaflops on their application base. What's going on in the EU right now? Lots of interesting developments in terms of building an indigenous HPC infrastructure. They really want to reduce some of their dependence on foreign capabilities, develop an indigenous HPC sector and all the feeder technologies that go into that. They've just announced that they're going to put 3 200 petaflop systems, one in Finland, one in Spain, and one in Italy. A sign of the times is the one in Finland is about a 4-hour drive north of Helsinki in a decommissioned paper factory. So it's a relatively cheap installation. And because it's cold up there an awful lot of time of the year, their cooling costs, electrical costs are really impressive. So this is the first, in my mind, a really good example of where big HPCs, how they're going to have to change how they're installed, how they operate. EU plans call for 2 exascale systems, 2022, 2023. One of them is going to be using the European Processor Initiative microprocessor. That's part of their indigenous, their thrust for indigenous technology development, with a post-exascale system coming around 2027. Interestingly enough, we talked to some folks from the UK recently. Brexit is on everybody's mind, and ultimately the thinking there is that the UK is ultimately going to have to build their own exascale system. They're going to have to stand something up, and they've already started the paperwork. There's been a strategic case outlined. They've already got some. They've actually picked out a site for the installation, and they're really looking for something in the 4th quarter of 2022 for a UK-based exascale machine that is separate from what's going on in the EU proper. To me, one of the more interesting ones right now is what's going on in Japan. They are starting to actually construct the Fugaku system. Fugaku is the Japanese term for Mount Fuji, and it's symbolic in many ways. The first one being that Mount Fuji is the tallest mountain in Japan, but it also has an incredibly wide base. It's a very slow sloping mountain. So the idea is that this machine, while being the fastest in Japan, will also have a wide use of applications. And to me, what comes out as being most interesting is this was co-designed with a set of applications that the Japanese felt were super important to do. And their greatest success is they typically got 37x improvements on their target co-design applications. This is, in my mind, a great example of kind of a post-LINPACK sophisticated perception of how you design a system. You design for the applications you want to do, and then you measure the performance increases on your specific workloads. Strictly speaking, this is not going to be an exascale system, but it'll probably be one of the most effective near exascale systems. I would argue the most effective HPC probably for the next 5 or 6 years when it comes to delivering performance on important use cases. So I've spoken for more than enough time, so I'm going to turn over to Alex, and he's going to give you a little bit about what's going on in the Innovation Awards.
Hello again, everyone. At ISC and SC, Hyperion Research, in conjunction with the User Forum, give out innovation awards. You can go to the website and you can see all the past award winners. We have 2 types of innovation awards. One is for end users who show impact of their HPC use to the community or to the world. The other side is we have vendor awards as well for vendors who make impressive innovations on the hardware side. So we have 2 winners in each of these categories this year. Just a little background on what the award program does. The bottom line is that the goal is to educate the community on new and interesting ways to use HPC to solve today's problems. So the end users and the vendors that are highlighted in the award program are looking at HPC to solve non-traditional HPC problems. They're looking at different ways to approach kind of the growing ecosystem that is HPC. And then the second part of that is that we can then collect these into a much larger database to understand the trends within HPC, the people who are doing the cutting edge stuff, the new workloads, and understand where the trends are. Just an example of some of the previous winners, you can see government labs, private sector companies, universities. Really, anyone who's doing interesting things in HPC can win an award. And we've seen that over the past many years that there are a number of variety of companies that have won awards. So to get into the awards, note that it now includes a $1,000 prize for the winners. So the first award is a team out of Argonne National Lab, which used a series of high spatial resolution physical-based models to assess risk analysis for AT&T. So looking at floods and weather and understanding how to accurately place and understand the risk of where they're kind of doing their installs. So if there's someone from the Argonne team, please come on up and we give them a... The next award is for a team based out of the Max Delbruck Center as well as the Zeus Institute in Berlin, who use CNNs, or convolutional neural networks, to help diagnose osteoarthritis through imaging. So they ran it on top of an AI platform. Is there anyone here from this award? Okay, let's just give them a round of applause. So now the two vendor awards. The first, as I mentioned earlier, this company, Cerberus, has created the largest computer chip. It's a wafer scale chip designed for AI. I think it has something like 1.2 trillion transistors and over 400,000 cores. Extremely interesting approach to AI hardware. Is there someone from Cerberus here? Let's give them is there someone here? And our final award goes to Sugan for their phase change cooling system. They use the 3M, the liquid cooling. And if you didn't see their demo at ISC, or if they're on the floor now, I would definitely check it out. The technology here is really interesting. They have a PUE of around 1.04 for this system. So really innovative use of liquid phase change cooling for high-density systems. So, is there a member from Sugan? Yes. Can we do?
Get everyone together for. Thank you very much,
And we really urge everyone to go and look and apply if you have really interesting and innovative use cases for HPC. And with that, I'll turn it over to Earl. Thank you.
Great, thanks, Alex. And so, Bob, with your presentation on exascale, is your new cheer "Go Alaska, Go Siberia"?
Exactly.
So a couple in conclusion, some predictions. As Bob was mentioning, the exascale race is driving new technologies, and we expect to see the traditional term, the trickle down, tremendously happening here in exascale. We think that's going to be a very interesting thing, because if you think of exascale and the plans 5 years ago, nobody was talking about really AI, big data, business analytics, regular analytics. And so we think the exascale systems themselves are being evolved along a very different path than originally was planned, which the good news to me at least is that they're being developed to be a much broader audience base for them. And that's where the convergence and everything else is coming from. The next one is that we see that the HPC enterprise market convergence that we've been talking about is going to drive a lot of HPC products into the broader enterprise space. As Steve was mentioning, I think we broke 200 examples. So this is not just one-off examples here and there. This is something very substantial that's happening. And it's really being driven by competitive forces. Once a major company makes a move in this direction, all the competitors have to catch up or they get left behind quite quickly. So as in the tipping point charts we're showing, we think this will be a very quick switchover that's going to happen. Also, the many new processors and accelerators on the way. Alex presented a number of them. We're now trying to track all of the AI hardware on Earth, and we likely will be in the hundreds. And now not all of them are processors. There's all different parts of hardware. But we're talking just a volume of different new technologies being developed. And of course, that's going to go through some kind of evolution in the sense of downsizing to the best win versus that. But at the moment, we're in the phase where there's just a tremendous number of processors. One thing that we're wondering about, does that mean the exascale systems and the post-exascale systems? Will we in a world where a supercomputer is going to have 10, 20 different types of processors in them? You know, we may be heterogeneous, maybe take on a completely different meaning at this point in time. The other big point we wanted to cover is storage systems are increasingly becoming more critical, especially as machine learning and deep learning graph analytics become more successful and actually used. The storage of data, the movement of data, where you place your data, your compute in that, we think are going to drive future architectures much more heavily than they have in the past. And then the last one is artificial intelligence is going to just grow faster than everything else that we're looking at right now. Every study that we're doing right now, people are moving from an experimental mode to actually doing something useful. But the usefulness is something that they're pointing to that they want to do 1,000-fold more. So the direction here is just some tremendous growth. We do think the trust transparency issue is real. And we do think that's what's going to hold back deep learning somewhat in this process. So if you notice in Steve's presentation, he had machine learning still being much stronger in the market than deep learning. We do think once some of the transparency issues are solved, deep learning will grow faster. But we think in the next 5 years, it's all about machine learning, quite frankly. And I'm talking about the larger sales in the market. And with that, I'd like to conclude, but also remind everyone, if you want a copy of the slides, please register. If we simply download everyone who registered with an email, then we mail out to that email list. So I want to thank everyone for joining us, and thank everyone again for participating in all our surveys. We really appreciate all the help.